Okay, so this is going to be our next topic within our moles, percent composition, empirical formulas unit. So it gets easier from here. So percent composition is going to be the percentage of whatever you're trying to find over the total mass. Okay, so it's pretty easy. So our first step whenever we're doing these types of questions is we have to find the formula weight. Okay, so aluminum, you got two aluminums. Aluminum weighs 27, 54. You get three S's. S weighs 32, it's 96. And then we have 12 oxygens. I don't know what that is, 192, I think. Is 192, yep. Okay, so we add them all together. So 54 plus 96 plus 192, you get 342. Now, the reason we set it up like this is because in this question it says calculate the percentage of sulfur. Okay, so we locate sulfur. Sulfur's right here. We do 96 over 342. And we multiply it by 100 to get it to a percentage. Yep. So 96 divided by 342 times 100 is 28.07%. Sulfur, and that's it. That's all you do. Nothing more to it. Now, if it says calculate the percent composition, okay, that assumes that you're going to do each element in that compound. Okay, so nitrogen, we got one nitrogen. Nitrogen weighs 14. You got four hydrogens at one each. And you got one chlorine. So we're going to say chlorine weighs 35. Okay, so we get 18 plus 35, 53. Okay, so it says we want to find the percent composition. So we're going to do the percentage for each element. So I'm going to label it like this. Percent nitrogen is 14 over 53 times 100. Your percent hydrogen is 4 over 53 times 100. And your percent chlorine is going to be 35 over 53 times 100. Okay, so we get 14 over 53 times 100. It's 26.42%. 4 over 53 times 100 is 7.55%. And then 35 over 53 times 100 is 66.04%. Now, common sense is going to tell you that your percentages should add up to something really, really, really close to 100%. Okay? So make sure you do that. And there's nothing more to it. Next example, it says, what is the mass of metal in 50 grams of aluminum oxide? Okay. So when we have a question like this, we are going to identify what the metal is. Okay? And we're going to find the percent metal. So in aluminum oxide, we have two aluminums, and we have three oxygens. Right? Now, your aluminum, if we're going to do our percentage of aluminum, because that's the metal, is 54 over 102 times 100. So we'll do 54 over 102 and divide it by, times 100, we get 52.94%. Now, once we get the percentage of aluminum, we're going to multiply it by 50 grams. Now, just FYI, So we have 50 grams of a substance, and 52% of it is, or 52.94% of it is going to be aluminum, okay? So when we multiply by a percentage, we've already done this before, you have to move the decimal place 2 places to the left, okay? So we'll do 50 times 0.5294, and we get 26.47 grams of aluminum. People like for me to explain it this way a lot better than an alternative way, so over the years it's kind of stuck. So you pretty much undo the work right here whenever you're multiplying, okay, by 100. Next example, it says calculate the percent composition of MnO2. Okay, so we're going to do for each element. So Mn, you have 1, and that weighs 55. Oxygen, you have 2, that weighs 16 each. So it's 87. So the percent Mn is going to be 55 over 87 times 100. And your percent oxygen is going to be 32 over 87 times 100. Okay, so 55 over 87 times 100, you get 63.22% Mn. And then 32 divided by 87 times 100, you get 36.78% oxygen. Okay? And I need you to organize it like this. It's easier to grade this way if you do it the way I do it. Okay? Now, calculate the percentage of water in calcium chloride dihydrate. Okay? So anytime something's bonded with water, and we're going to see this in lab, it's called a hydrate, okay? So it has water inside of it. When you heat it up, the water goes away, okay? So it's pretty much the same type of question. We're gonna do our molecular weight first, okay? So calcium, we got 1 calcium. Calcium was 40. Chlorine, we got 2 chlorines. I'm gonna say it weighs 35. And then I'm going to go over here and do water, okay? So water, we have 2 waters because, we have a 2 in front right here, and, it's ball. Okay, so we've got 2 waters, and let's use a little bit of common sense. Water, we got 2 H's, and 1 oxygen weighs 16, so 2 plus 16 is 18, so water weighs 18. We're not going to split it up. We're going to leave it just like that. So it's 36. Now, what we're going to do is we're going to find the total mass. So we do 110 plus 36 is 146. Now, if we want to find the percent of water, you do 36 over 146 times 100. Okay, so 36 over 146 times 100, and I get 24.66%. Okay, now, so that's how we work a hydrate question. So we find the molecular weight, just like we did before. We keep water as H2O. We're not going to split it up into individual atoms. Okay, water weighs 18. This is where it came from. 2 times 1 is 2. Plus 16 from the oxygen is where you get the 18. Then you take and you find the total mass. 110 plus 36 gives you 146. The percentage of the water is going to be the 36 over 146, and you multiply by 100. Okay, so that's been your percent composition notes. The next video, I'll go over your percent composition practice problems. Thanks, and have a good day.